Well, welcome, ladies and gentlemen, to the final Live on Tap of the spring semester 2016. We've had a great slate of speakers all the way through the past few months, and I'm really excited to finish off with a great alumnus, Dr. Phil O'Haron, who's here to talk a little bit about his work in neuroscience. Before I introduce Dr. O'Haron, I just want to say it's really interesting what's going on in the STEM field right now. There was a report that came out in Forbes where Silicon Valley people that are computer science experts, they're looking for liberal art educated majors. And it's interesting because they said the people that they're getting that are computer science majors in these other large research universities, by the time they graduate, the knowledge that they're gaining is outdated. So by the time they get to Silicon Valley, they have to be retrained anyway. And this report highlighted the fact that liberal arts majors, you have those critical thinking skills, and they're able to easily transition into a scientific field like that. Now, I know in the medical field, there's a lot of technical terminology and a lot of experience that you need to gain firsthand. And so I'm really excited to have Dr. O'Haron here to explain how you can take that step from graduating from here to transitioning into a medical program. So just to give Dr. O'Haron a brief introduction, he's a 2000 philosophy major. He ended up getting his PhD in neuroscience from the prestigious Johns Hopkins University. And he's currently a postdoctorate fellow at the Medical University of South Carolina. So without further ado, Dr. O'Haron.
Thanks, Greg. It's nice to be here. It's nice to be back after all these years. And it's great to be able to participate in what seems like a really good program that your career office here has. Okay? Is it loud enough? Right. A little louder? Am I supposed to use these things or no? I can be louder. All right, so I think I'll start off with just my story of how I got from Christendom to where I am now. Since it's a bit of an unconventional route, I guess. There's not too many liberal arts majors in science research that I've encountered. And hopefully, as I go through that, I can give you at least some general ideas of what scientists do beyond just what I do. Unfortunately, I know mostly about what I do, but and then give you an idea of what sort of the day-to-day life of a scientist is like. So in high school, I liked science. I was interested in science. I liked the science classes. I don't think I knew what neuroscience was in high school, but I think if somebody had asked me what I wanted to be when I grew up, I probably would have put scientist on the list. But I came to Christendom. That's just what we did. My dad taught here. We got free tuition. Didn't really have to think about it. And I loved it here. I loved the people. I met my wife here. I loved the courses, especially philosophy. So I became a philosophy major. And I think it was really in studying philosophy that I became interested in the brain. I loved philosophy of human nature and thinking about, what is it that makes us human, what makes us so special, and, how do we know the world, and these kind of difficult philosophical questions. And I started to think, it'd be nice to know how the brain works. So I'd heard about this neuroscience thing where people study the brain and decided, that's what I'm going to be when I grow up, as a neuroscientist. And I've basically been, chasing that dream ever since. It can be a long process, and I feel like I'm almost there. But so after Christendom, I didn't have any science background, and so I wanted to take a few years of undergraduate science level courses to get into a graduate program in neuroscience. And I didn't know really what I was doing, so I emailed some random neuroscientist I found online, probably from one of the state schools, and just told him my story and said, what classes should I take? And I didn't get really the best advice. That's something that I could have maybe gotten better advice on. I didn't realize how diverse neuroscience can be. You can be a neuroscientist at so many different scales. You could be a geneticist, and study how genes get turned on and off, in different brain states, or when an animal learns something. You could be a biochemist or a molecular biologist and study how certain molecules in the brain are performing certain functions or get screwed up, in disease states or something. You can be an anatomist and study how brain areas connect to each other, or how the brains of different species are different. You can be a physiologist, like what I ended up being, and you study the response properties of a whole cell and how they encode information. You can study sort of whole chunks of the brain and how they perform certain tasks. You could be a psychologist and just deal with human perception and have human beings give you reports of their perception of different things. And you can be a computer scientist and make computer models of the brain, try and learn about how the brain works from the parameters of your model. So there's all these different ways of being a neuroscientist. And so the person who I emailed studied neuroscience at this very molecular, sort of small scale level, and I was interested in studying at a bit of a higher level. So I took some courses that weren't maybe necessary and missed out on some that I would have taken if I had known better. So just a cautionary tale, if you do want to get into some kind of science field, ask around, talk to as many people as you can to get the best advice possible about what route to take. Anyway, so after 2 years of science classes, I got into the neuroscience program at Johns Hopkins. And again, I really didn't know what I was getting into or doing, but I honed in pretty quickly on monkey vision. I thought it was really cool. These guys have monkeys that are awake. They're looking at a computer screen. You can teach them to do different tasks, and then they put a little wire electrode into the brain and record the activity of a single cell in the brain while the monkey's doing something. I just thought, wow, this is so cool. This is what I want to do. So, it wasn't any deep philosophical question we were addressing. The lab studied how the visual system segments a scene into foreground and background objects, basically. But I thought the questions were interesting, and I thought it was neat to think about how you can design experiments to probe how the brain encodes this kind of information. So I did a PhD for 7 years, and I loved it. I loved working with the animals, training the animals. I loved doing the experiments. I loved analyzing the data. All of it was just great. I loved what I was doing there. So then after 7 years, I had gotten a neat result, but only in one monkey, and you have to have data from 2 monkeys to publish it, just in case your one monkey is a freak. So my boss kindly offered to let me wrap up my thesis and then hire me as a postdoc to do the second monkey so we could get a paper out of it. So really the only difference between being a postdoc and a grad student was he would pay me more, so it was kind of nice of him. So I did that for 2 years, and we got data and we got a nice paper out of it. But I knew I had to do another postdoc if I wanted to get a faculty position. It's not like in the humanities, I guess, you go to grad school in philosophy or history. Usually when you get your PhD, I think you immediately start looking for a faculty position. But in the science, nobody does that. You get your PhD and then you have to do another postdoctoral research stint where you just do the same thing you were doing as a grad student. There's no courses, there's no degree, but you slave away in a lab collecting data in the hopes that you can get a paper. And the labs need papers to get funding, and they need funding to hire more people to do more experiments, and so on. But so I needed to do another postdoc, and so I was thinking about what I wanted to learn, what I wanted to do a postdoc in. And so as I said, we would put an electrode into the brain and record from one cell at a time in the monkeys. And this could be a pretty painstaking process. You'd have this whole battery of stimuli that you had to present while you were recording the activity from a cell. And if you lost the cell during the sequence, then you had to start over. You couldn't use any of that data. So you might accidentally poke the cell and kill it, or the electrode might drift away, and you just lose the signal. So a whole day might go by, and you get no usable data. And if you're lucky, you could get an average of 1 or 2 cells a day. But I heard about these, as I was doing this day after day, slaving away. These papers were coming out where people were putting an animal under a microscope and taking an image of the brain, and they could see hundreds of cells at a time. And they weren't using electrodes to measure the activity. They were using this fluorescent molecule. So when the cells became active, they got real bright. And so, I saw this where it might take me a whole year to get data from 300 cells. These guys were doing it in one day. And so I thought, yeah, this is what I need to do. This is what I want to learn. So I found a lab that was doing that would take me on as a postdoc. And that's the lab in Charleston, South Carolina, where I am now. We do things a little differently there. We work with cats, not monkeys, and they're anesthetized. And like I said, we do this microscope imaging technique. But I love that too. I think it's a great technique. I'm really glad I went there and learned that. And it's fascinating and fun to do. Okay, so the typical day-to-day life, whether you're a grad student or a postdoc, is doing experiments and analyzing data. That's what we spend most of our time on. it depends on what kind of work you're in, how much of those two things you do. For me, analyzing data mostly consists of writing computer code to open data files and pull things out and group them and extract information you want, and then do statistical tests, make pretty plots, things like that. So I do a lot more data analysis than actual experiments. But different types of scientists may have the opposite. And then there's the boring nitty-gritty things you have to do from time to time. Also, cleaning things, ordering supplies. But that's sort of what the day-to-day life of a student or postdoc is. And it can be great. I love what I do. I love the science. Anytime you're doing an experiment, you might be the first person ever to learn something about the brain. To learn some particular thing about the brain. And so I love that kind of thrill of, you're right there watching the brain in action. Usually you have to analyze data to learn something because it's hard to get it just watching. But even then, you might spend months working on your code and debugging and struggling. And then finally, you get it to spit out the graph or the numbers that you wanted, and there it is, you've learned something new. So that's very exciting. It's very kind of an intellectually rewarding kind of work. But it's not all peaches and cream. There's a lot of bad days and things you have to slog through. So I'll just give you a quick overview of some of that. So yeah, like I said, it can be hard work. Most of the time, your experiments don't work. You spend most of your time tweaking, trying another experiment, trying to figure out what went wrong. When you're lucky, eventually it works, and you start to get the data you want. But then things go very quickly. So it usually takes a long time to get to that point. You do get paid to be a grad student, so that's kind of a nice thing, especially for people who are thinking about grad school in the humanities. I don't think you usually get a stipend, but you do get paid to be a grad student in the sciences. It's not great pay, but it's better than minimum wage. And you work for it, though. You're a full-time employee of the lab. You take a few courses your first couple years. You maybe go to seminars and conferences once in a while to sort of keep up on the field. But mostly you work in the lab. And it can be tough. Sometimes it can be very long hours, especially when your experiments aren't working. Just last week I was doing a mouse experiment and I was in the lab till midnight because I kept losing the water under my microscope objective. It's a stupid thing that should never happen, and it cost me 5 hours. So there are days when you just want to take a baseball bat to everything, destroy it all. But in the end, it finally did work, and I got some nice data. And so then it pays off in the end. But it can be, there can be some long, hard hours. I remember one old scientist saying, if you don't put in a minimum of 60 hours a week, you're a fake scientist. I don't know what that makes me most weeks, and then the other thing is, maybe you don't get a real good result, and then it's hard to publish. So, the life of the scientist is publishing. If you don't publish, publish or perish. That's true in science, like a lot of other fields. So, if you're lucky in your PhD, you get a good result, and you can write a thesis and publish a paper, and then you can go on to do a postdoc. And you get lucky again, you get another good result and a good paper, and then maybe you can get a faculty position. A fellow postdoc, friend of mine down at MUSC, was just telling me the other day that he saw something that said less than 25% of PhDs, at least in the life sciences, end up with a faculty position. So it sounds pretty bad. But there are a lot of other things you can do with a PhD in science. Unfortunately, I don't know a lot of what those things are, because when they have this kind of event for people like me, I never go. I just am sort of one-track minded. Like, I want to be a faculty. I want to have a lab at a research university and teach and run the lab. So I don't really put any thought into like a plan B. But they have these kinds of things where people come and alternative careers in science, and they do things like what I do and say, you can go into this field, you can go into that field. So it is out there, and if somebody thinks they want to do something like science but don't want to run a lab at a research university, there are a lot of other options. I could probably tell you some of them, or at least point you to some people who could tell you more about them, depending on what field you're interested in. Bad pay, long hours, and poor job prospects. Should I go on? I know you're all saying, hey, where do I sign up, right? No, but it's just, if you want a job that just puts food on the table, it's probably not where you want to start. nothing wrong with jobs like that. Trust me, when I'm there late in the lab, I often think, I could have just had a simple 9-to-5 kind of job and probably been paid more and be at home right now. But if you do love it, I think it can be great. I mean, I really love what I do, and I'm glad I do it. Yeah, there are times when you wonder, but those are much more rare than the times when you like, at least for me, when I like what I'm doing. Now for the last part, I wanted to talk about the benefits of a Christendom education. Again, it's kind of an uncommon way to get into science. And on the one hand, I kind of think, well, I don't really use a whole lot of philosophy and history in my day-to-day job, or week to week, or month to month. I think once I tried to use Latin. There was some anatomical structure that had a Latin name, and we were trying to figure out what the plural form should be. But I all those years of Latin, I bombed. I couldn't do it. So my one chance to show off my liberal arts chops, and I blew it. But as you all I'm sure know and have heard before, whether it's from speakers up here or I remember when we first came to Christendom, one of the first things you talk about is the goal of the liberal arts education, right? Even as Greg alluded to, in the introduction, it's not to train a person to do a specific job. It's to educate the whole person, right? It's to form you well, and then you pick up skills from that allow you to succeed in anything. So the critical thinking skills and the writing skills, and that's definitely true in science. Critical thinking is something you have to do every day. I read a paper and I see the data, and then I read what the authors conclude from it. And I have to decide, is that a valid conclusion? Are they missing something? Is there some other interpretation? So that's not all that different from reading a philosopher and seeing, are there holes in his argument? And where are they? And what would need to be done to fix them? And even in your own work, you may have some expectation from your data. Is that a valid expectation? Is there some other reason that it could be giving you the same data? Or you don't see what you expected, and you have to go back and think, okay, what was wrong in my hypothesis? Where do I go from here? I got to start with something new. So, you're doing critical thinking really all the time. So there's definitely that component, which, again, I think is true of really almost any field, that a liberal arts education can be useful. But I wanted to emphasize some other benefits of the Christendom education that I've found especially helpful or good. And that stems, scientific academia, it's a pretty atheistic world. I'm not sure, if I've ever met another graduate student or professor who was even a believer. Maybe some graduate students, but not the ones in my lab. And so, at a simple level, it's kind of good to have that knowledge base to know, there are solid reasons for your faith. Occasionally you will encounter somebody who's just shocked that a seemingly normal and intelligent person believes in God. They didn't think that existed. But that's not the common experience, at least for me. What's much more common is that you meet people who are interested and want to talk about it. And again, I may be the only theist that most of these guys will meet, in this field. And so to have that, and they may want to talk about anything. It can be philosophical arguments for the existence of God. It can be particulars of church teaching or the Bible. It can be, history. Jesus is a historical figure, or the church's bad behavior through history, Galileo and the Inquisition and all that. It can just be kind of general historical, cultural things. Is religion good or bad for people, for societies? People ask this. They want to know what I think and why. And so it's great to have this broad background that you get from Christendom, that I got from Christendom. It's like a treasure chest of facts, that I can go back to and pull out, and I can discuss any of these topics with these guys. And there's no way I would have been able to do that with, having gone to a big state school and majored in science and tried to pick up a little religion on the side or something. I could take a class or read a book and learn the computer programming and electrical engineering that I need, but there would be no substitute for that kind of broad base education that you'd get here. And another sort of component of that, since I'm just going to keep going, since there's nobody else, that I really enjoy about it is, the science work, it's very intellectually stimulating. You're using your intellect and your mind a lot every day. You're thinking about things, you're learning new things. You read a paper that other people publish and learn something new. I have to look things up all the time. So I mean, I go to Wikipedia, many times a week and learn something new, some equation or something. So it's very intellectually stimulating, but it's kind of only one part of, the whole realm of human nature, of our intellectual nature. There's the whole other sort of philosophical, spiritual, artistic side of human nature that you don't get stimulated, when you do science work. And so I think, you can spend all day, digging into this cell and this particular detail of one particular thing in the brain, and it can be intellectually rewarding in some ways, but then, it's nice to be able to kind of go home and leave that behind and again, kind of dip back into this sort of treasure chest of knowledge, and, you can think about, some big philosophical question, or, the great spiritual writers, or the great books of history, the stories of history, of human nature, and so on. And it's kind of very refreshing in a way. It feeds this other side of our human nature. And again, I think there's no substitute for that. And there's no way you could kind of pick that up on your own. I mean, yeah, you could go to an art museum and so on, but there's just such a richness that you get from a Christendom education. And I think particularly in the science field, it's those aspects that I'm most really appreciative of for having come here. So I think that's all I have. Again, if somebody's interested in going into sciences, I would say you can do it. I said some negative things there, but I really love it. I did it. I support a family on it. Just make sure you find something that you do like, and I think the best way to do that is to talk to as many people as you can, ask around, even take some courses in different fields if you're not sure. And if you find you're doing something you don't like, then switch. Don't get stuck for 10 years before you decide to start your career over again. And I guess that's all.